Let's do this question, okay? This question I got from your K2 prescribed textbook. That is, the name of the textbook is that Sudhakar textbook, Circuits and Networks Analysis Synthesis. From there only I got this problem, okay? So because when I read this question is not like your usual question, right? Here they're asking us to find the resistors, the value of the resistors using mesh analysis. Find the value of R1 and R2 in the network using mesh analysis. So here you can see that here there is a resistor R1 and here resistor R2. So using mesh analysis, find R1 and R2. That is the name of this. That is the question they have asked for this. So here we do the normal procedure. We apply I1, I2 and I3 and then we write the mesh equations, okay? But here this is slightly different. See, because usually we write the mesh equations in terms of I1, I2 and I3, right? But here we don't need to write I1, we don't need to find in terms of I1, I2 and I3 because that's not what they have asked here. I1 and I2 and I3, here the current of these two branches are already given. So that makes the equation more and more simpler, right? So all we need to do is focus on finding R1 and R2. That should be our aim. So there are different ways of approaching this problem, okay? So you can choose. So I suggest all of you to pause this video and try to solve this question by yourself, all right? Apply Kirchhoff's voltage law to each and every one of these measures and then try to find the value of R1 and R2, okay? Then one more thing also I want to tell you before doing this video or before doing this problem is that when I found and when I did this problem by myself, I found the answer and that answer is different from the answer in the textbook. Okay, so I was having a doubt whether I made a mistake somewhere and I checked again and again. I couldn't find any mistake. Then what I did is that I did the same problem using node analysis. And after doing the node analysis, I still got the same answer what I got for mesh analysis. Okay, I did not get the answer of what is written in the textbook. Right, so I'm assuming that answer what I have got from here is correct. Okay, so I want all of you to do your own method, and if you are very sure of your answer that you have written is correct, then please contact me, okay, or write any comment on the YouTube section. Okay, just write any comments, okay, just to show that you got a different answer from me. I'm a bit confident that my answer is correct because I applied two methods in this problem, both mesh analysis as well as node analysis, and for both the analysis I'm getting the same value of R1 R2. That is not a coincidence. Okay, so I think my answer is correct. So anyway, let's do this problem, right? So here as usual what we do is I mark the mesh current I1, I2 and I3 as usual. Okay, then I write the equation for mesh 1, mesh 2 and mesh 3. So equation for mesh 1. So here, like I said before, there is no need of writing this equation in terms of I1, right? We just need to apply Kirchhoff's voltage law in this equation. That's all. Okay, so what is Kirchhoff's voltage law in this equation? That is the voltage across this plus the voltage across this is equal to the voltage source, right? That is Kirchhoff's voltage law. Voltage across this plus voltage across this is equal to voltage of the voltage source. That is the Kirchhoff's voltage law. So which means what is the voltage across this resistor? The current across this is assumed to be I1. So it is 0.1 I1. So 0.1 I1 is the voltage across this plus, now what is the voltage across this? This current is flowing in the same direction as I1, right? This current is flowing the same direction as I1. So therefore the potential difference is from higher potential to a lower potential, right? So I mean this is flowing the same direction. This 20 amperes flowing the same direction of I1. So this is plus, and what is the voltage across R1? Current across R1 into R1, right? V is equal to IR. This is I and this is R. Therefore, voltage across R1 is this. 20 R1 is the voltage across R1. So voltage across 0.1 ohm resistor is 0.1 I1 and the voltage across the R1 resistor is 20 R1 is equal to, and the voltage source See, this positive terminal is generating current I1, so it is plus 100, right? So this is the equation, okay? Because the reason, usually how you write is you substitute instead of 20 amperes, usually for the previous problems and all, instead of 20 amperes it used to be I1 minus I2, right? But here instead of I1 minus I2 they gave the direct answer, they gave 20 amperes. That's all, that's the only difference, okay? The same way, the equation for mesh 2, all right? So in mesh 2, okay, we don't need to write this equation in terms of I2 or I1 or I3 because already the name of the current is already given here, so this question, so the equation becomes more simpler, right? So over here, if you look over here, 20 amperes is flowing downwards, whereas this I2 current is clockwise, right? And it's clockwise, so it is going upwards. In this branch, 20 amperes is going down and I2 is going up. I2 is going up. So which means this potential difference over here is opposite to that of the potential difference incurred by I2, which means this is minus 20 R1, right? Minus 20 R1, that is the voltage across this resistors, minus 20 R1, okay, plus voltage across this is 0.3 I2, there you are, and voltage across this, right? So here both I2 and 30 amperes are flowing in the same direction, right? Both I2 and 30 amperes is flowing into the same direction, which means this is plus 30 R2, right? 20 R1 is the voltage across this resistor, 0.3 I2 is the voltage across this resistor, and 30 R2 is the voltage across this resistor, and all this is equal to, there is no voltage source over here, so it is equal to 0. Okay, next equation for mesh 3. Okay, equation for mesh 3. So here I3 is flowing opposite to that of 30 amperes, which means the potential difference is also opposite, right? Because here according to this current, the potential difference is plus and minus, right? Always the current flows from a higher potential to a lower potential, but the current that you assumed, I3, is flowing in the opposite direction of the potential difference, which means this is the voltage across R2 in mesh 3. The voltage across R2 is this, right? Minus 30 R2 is the voltage across this resistor, plus 0.2 I3, right? 0.2 I3 is equal to, and this I3 current is flowing into the supply, it is flowing into the positive terminal, right? That means this positive terminal is not generating current, it is opposing the current, so which means it is minus 120. So these are the three equations, and these are not only the three equations, like I said before, right? Like I said, I haven't written the equation for 20 amperes. What is the equation for 20 amperes? Also I1 minus I2 is equal to 20 amperes, right? That's the equation for 20 amperes. And what is the equation for 30 amperes? I2 minus I3, right? Because this is flowing down, which means then I2 is greater. Here this is also flowing down, which means I1 is greater. So I2 minus I3 is equal to 30 amperes. Okay. So basically there are how many unknown variables? I1, I2, I3, R1 and R2, which means there are 5 unknown variables. So 5 unknown variables means you should have 5 equations. 1, 2, 3, 4, 5. So you have 5 equations. So now you can solve for R1 and R2. Okay. So how I am going to solve is, I am going to solve like how I solved like the previous problem. Exactly that. Okay, the only difference is that instead of I2 and I3, the equations are all going to have R1 and R2, which means I'm going to substitute every value of I2 and I3 with I1. That's I believe that's the easiest way. Okay, or you can do your own method of solving. The only important thing is finding the value of R1, R2. So see how I'm going to find the value of R1, R2. First, what I'm going to do is I'm going to remove I2 and I3 from this equation. That's what I'm going to do. Equation 1 is as it is. Okay, I'm not going to make any change in equation 1 because equation 1 contains I1 and R1. Whereas over here, I want R1, I want R2, but I don't need I2, right? So what I'm going to do is I'm going to change the value of I2. We know that from here I can say that I2 is equal to, let me see, I2 is equal to I1 minus 20. I2 is equal to I1 minus 20. So I can substitute I1 minus 20 over here. And what about over here? Here also, let me see, I3, right? I3 is equal to I2 minus 30. So I3 is equal to I2 minus 30. But what is I2? I2 is I1 minus 20. So this is basically I1 minus 20 minus 30 is minus 50. So therefore I3 is equal to I1 minus 50. I2 is equal to I1 minus 20. So which means in this equation I am going to substitute I2 as I1 minus 20, and in this equation I am going to substitute I3 as I1 minus 50. So basically these three equations will have only I1, R1 and R2. Okay, so this is how I am going to simplify the equation. So which means this equation, right? Let me mark the equations. Okay, basically from here on I want you all to do this by yourself and find the value of R1 and R2. You don't have to follow up the same exact procedure what I am doing. Okay, this is for my own benefit. So this is minus 20 R1, right? Equation 2 minus 20 R1. Let me write like that. That is equation 2 becomes, okay, minus 20 R1 plus 0.3 I2. And what is I2? I1 minus 20. So I1 minus 20 plus 30 R2 equal to 0, right? Or this can also be written as minus 20 R1 plus 0.3 I1, okay, minus what is 0.3 into 20 is 6, minus 6 plus 30 R2 is equal to 0, right? Or in other words, I can say that 0.3 I1 minus 20 R1 plus 30 R2 is equal to 6. Okay, this is my equation. Okay, this is my modified equation of mesh 2, right, which contains only I1, R1 and R2. There is no I2 and there is no I3. There is no need for I2 and I3, right? So that's it. That's one equation. Now, and as for the other equation for mesh 3 also, let me see, let me write it. Equation 3 becomes, let me see, minus 30 R2, all right, minus 30 R2, okay, plus 0.2, and instead of I3 I will write I3 is equal to I1 minus 50. So which means I will write over here I1 minus 50, okay, I1 minus, yes, over here I1 minus 50 is equal to minus 120, is equal to minus 120. This can also be written as minus 30 R2 plus 0.2 I1 and 0.2 minus 50. 0.2 into minus 50 is minus 10, is equal to minus 120, right? So which, in other words, I'm going to say that 0.2 I1 minus 30 R2 is equal to minus 120 plus 10 is minus 110. Okay, so now I found the new equations, right? So what are the various equations which I'm going to use to find R1 and R2? Just like your normal mesh analysis, instead of I1, I2 and I3, it's going to be I1, R1 and R2. I1, R1 and R2. So that means let me write those equations again so you will be able to understand it. So it will be 0.I1, 0.I1, okay, plus 20R1 is equal to 100. This is the first equation that I got. Okay. The second equation I got is this one. 0.3I1, 0.3I1 minus 20R1 minus 20R1 plus 30R2 minus 20R1 plus 30R2 is equal to 6. Is equal to 6. This is the second equation I got, and the third equation is this one over here. That is 0.2I1 and there is no R1 minus 30R1 minus 30R2 is equal to minus 110. There. Let me check if I have made any mistake somewhere, since I am not that perfect. Okay, I hope I haven't made any mistake anywhere. Okay, so these are the three equations, right? If you can see, these three equations only has I1, R1 and R2. I1, R1 and R2. Just like in the previous problems, there used to be I1, I2 and I3. Here it is I1, R1 and R2. So now I'm going to apply matrix form in this equations. So which means three equations, three rows. The coefficients of I1 is 0.1, 0. The coefficient of I1 is 0.1. In the first, let's talk about the first equation. The coefficient of R1 is 20 and the coefficient of R2 is 0 because there is no R2 in the first equation, right? And what about the second equation? The coefficient of I1 is 0.3. The coefficient of R1 is minus 20 and the coefficient of R2 is plus 30. And for the third equation, the coefficient of I1 is 0.2. Okay. The coefficient of R1 is 0 and the coefficient of R2 is minus 30. Okay. The arrangement is I1, R1 and then R2, right? In all this equation I have written like that. I1, R1, R2. Here R2 is 0. Here R2 coefficient R2 is 0. Here it is 0.3 minus 20, 30. Here 0.2 I1, R1 is 0 and R2 is minus 30. So that's why I have written like this. I1, R1, R2 is equal to, and the other side of the equation is 100, 6 and minus 110. Okay. Same thing. Now this is exactly same like how your mesh analysis of your previous problems, right? So but here all you need to do is find R1 and R2, right? So what is the equation for R1? R1 is equal to the determinant of, here R1 is the second, it's the second row, right? Which means the second column has to be replaced with this, which means 0.1, 0.3, 0.2 and here it is second column is 100, 6 and minus 110 and the third column is the same, 0, 30 minus 30. Okay, and the denominator will be the coefficient matrix 0.1, 0.3, 0.2, 20 minus 20, 0, 0, 30 minus 30. Okay, and this is equal to, let me find the value, this is 0.1, right? 0.1 into, and this is minus 180, and this is plus, this is 3300, okay, minus 100 into, let me see, 0.3 into minus 30 is 3 into 3 is 9, so it is minus 9 and okay, and here it is 0.2 into 30. 0.2 into 30 is 2 into 3 is 6, so it will be minus 6. Minus 6, okay. Plus 0 into, that doesn't matter, so divide by, and as for the denominator, we have 0.1 into, this is minus 20 into minus 30 is 600, right? Then we have minus 20 into, let me see, 0.3 into minus 30 is 9 again, and again into minus 6, right? Minus 9, sorry, minus 9 minus 6, okay, plus 0, that doesn't matter again. So you got this, so which means this is again nothing but, let me see, what is 3300 minus 180? 3300 minus 180 is equal to 3120, which means it is 312. 0.1 into 3120 is 312, which is, this is 312, right? Minus, and over here it is, this is minus 15, so this is minus of minus is plus, right? Minus of minus is plus, so this means this is plus 1500, plus 1500 divided by, and at the denominator we have 60. 600 to 0.1 is 60, and here you have, this is minus of minus is plus, and 20 into 15 is 300. It's 300, which means you get, the denominator is 360. So now I can use the same denominator to find R2, right? And here it is 1500 plus, sorry, plus 312. We have 1812, which means R1 is 1812 divided by 360, which is 5.033 ohms. This is the same answer I got in the previous problem. Even when I did the node analysis also, I got the same answer, which, that is why I'm confident that this answer is correct, okay. Anyway, I can make a mistake, so please check if I got the same answer, if you all got the same answer, okay. So this is the equation for R1. Now next is to find R2, and to find R2 you can see that R2 is in the third row, which means I need to replace the third column with this, okay. So which means R2 is nothing but the determinant of 0.1, 0.3, 0.2, and the second column is also same, right? 20 minus 20, 0, and the third column is replaced with this 100, 6 minus 1 is 0, divide by, and your determinant is 0.1, 0.3, 0.2, 20 minus 20, 0, 0, 30 minus 30, okay. And this is equal to, so let's find the answer of this. This is 0.1 into, and this is 2200, right? This is 2200, and minus, there's nothing, so that's it, minus 20 into, and this is 33, right? I believe this is 33. 11 into 3, this is minus 33, minus 33, minus, this is 1.2, right? Minus 1.2, minus 33 minus 1.2, minus 33 minus 1.2, okay, plus 100 into, and here you have 0, and here this is 0, this is minus 4, which means this is nothing but plus 4. This becomes plus 4. And the whole thing is divided by, and the denominator over here is same, so that is 360. 360, which means, let's see, R2 is equal to, R2 is equal to 0.1 into 2200 becomes 220, 220, right? Minus 20 into minus 33 minus 1.2 is minus 34.2. So minus 34.2. Okay, and here it is plus 400. Plus 400, and the whole thing is divided by 360. 360. This is the value of R2. Let's see what the answer you get. So R1 I got. Now R2 is bracket 220 minus. So minus of minus is plus, right? So I don't need to make that minus again. So I can make this plus. Okay. So which means I can make this also plus. So again bracket 20 into 34.2. 20 into 34.2. Okay. It's not 30, it's 20. 20 into 34.2. Okay. Plus 400. 400. Close the bracket. Divide by 360. And you get 3.622. This is the answer this is the same answer I got when I did node analysis also, right? So this is the value of R1 and R2, right? This the value of R1 I got is 5.033 ohms, and the value of R2 is 3.622 ohms. Okay. So this is the answer I got. Please, if you are getting any other answer, please contact me. All right. According to your textbook, for those of you who are having doubt, let me just see. According to your textbook, the answer that I have written here is, where is it? The answer that I have written here is according to the textbook, okay? So it may be correct or may not be correct, but I don't think it's correct because I applied both mesh analysis and node analysis and I'm getting the same answer. But anyway, I'll just write the answer that's written in the textbook. That is R1. They said R1 is 4.88 ohms. Okay. According to textbook, R1 is 4.88 ohms and R2 is 3.82 ohms. Okay. So the answer what I got was R1 is equal to, let me see what I got for R1. R1 is 5.033 ohms. I've got 5.033 ohms, and R2 I got was 3.622 ohms. Okay, so this is the answer I got. This is the answer that the textbook has is written in the textbook. Okay, so this answer I got both for mesh analysis and node analysis. That's why I'm confident this answer is correct, but still I just want you all to just verify, okay, and see if you are getting this answer. All right.